In a groundbreaking development for space exploration, NASA has announced a promising new concept designed to facilitate ultra-efficient round-trip missions to Mars, leveraging a novel approach known as integrated cooling through inductively coupled LED emission, or Mars ICICLE. This innovative technology aims to address one of the most significant challenges facing Mars missions: the effective storage of cryogenic propellants, particularly liquid hydrogen, which is crucial for high-specific impulse nuclear thermal propulsion systems. The excitement surrounding Mars exploration has surged in recent years, bolstered by robotic missions that have captivated public interest with stunning images and data. As NASA intensifies its efforts to prepare for human exploration of Mars, the agency recognizes that successful missions will hinge on developing capabilities that allow astronauts to travel safely to the Red Planet and return home. Aaswath Pattabhi Raman, a researcher from UCLA involved in the project, emphasizes the importance of efficient, flexible, and productive round-trip missions, stating that new round-trip mission concepts need substantially improved long-duration storage of cryogenic propellants. The Mars ICICLE concept introduces a solution to the vexing problem of boil-off, a phenomenon where cryogenic liquids gradually vaporize and escape into space due to residual heating from various environmental sources, including sunlight and thermal radiation. This loss of propellant can significantly hamper mission objectives, leaving spacecraft with insufficient fuel to complete their journeys. To combat this, the proposed storage tanks will utilize a cooling technology known as electroluminescent cooling (ELC), which enables the rejection of heat efficiently from cold solid surfaces. The design aims to maintain the temperature of cryogenic liquids below their boiling points, ensuring that propellant reserves remain intact for mission-critical maneuvers. As Raman explains, a well-designed cryogenic propellant storage tank can reflect the vast majority of photons incident on the spacecraft, but not all. In thermal environments like low Earth orbit, even a small amount of heat can lead to significant losses. By integrating ELC into the storage tanks, the Mars ICICLE concept could drastically reduce the cost and complexity of propulsion systems for crewed Mars missions and other deep space exploration endeavors. The implications of this technological advancement extend beyond Mars missions. By enabling spacecraft to refill propellant tanks in orbit, NASA could streamline mission architectures and reduce the size of rockets needed for launching crewed vehicles. This shift could lead to a more sustainable approach to deep space exploration, allowing for a higher frequency of missions while lowering overall costs. As NASA continues to refine this concept, the agency remains committed to pushing the boundaries of space exploration. The potential for Mars ICICLE to revolutionize how we approach interplanetary travel is immense, setting the stage for future missions that could one day see humans establish a permanent presence on Mars. With ongoing advancements in technology and an unwavering commitment to exploration, the dream of sending humans to Mars and bringing them safely home is becoming increasingly tangible. As these developments unfold, the space community eagerly anticipates the next steps in this exciting journey into the cosmos. On May 27, 2025, NASA provided a glimpse into the ongoing operations aboard the International Space Station (ISS), where astronauts are engaged in critical biomedical research and advanced robotic maintenance. Amid the backdrop of Earth's stunning landscapes, Expedition 73 crew members are pushing the boundaries of human understanding regarding life and microgravity, revealing how the rigors of space travel affect our health and well-being. As part of their rigorous scientific agenda, the crew is focusing on how weightlessness impacts the cardiovascular and immune systems of astronauts. This effort is crucial considering the long-term ambitions of space exploration and potential missions to Mars and beyond. Humans are learning how to survive in space after millennia of evolution in Earth's gravity, remarked a NASA spokesperson. The constant collection of data from the various human research studies aboard the ISS contributes to a growing knowledge base about space biology, aiding in the formulation of exercise regimens, nutritional plans, and health therapies for astronauts. Two key figures in this research are NASA astronaut Johnny Kim and JAXA Commander Takuya Onishi. Kim utilized the Echo teleoperated ultrasound system to examine his cardiac function. while Onishi analyzed blood and saliva samples to assess how spaceflight factors such as microgravity and radiation influence cellular immune response. These studies are not merely academic, they are vital for ensuring the health and safety of astronauts on extended missions. In addition to health studies, the crew is also engaged in maintaining the ISS's life support systems. During a recent shift, Kim and Onishi assisted NASA flight engineer Nicole Ayers in replacing components of an innovative carbon dioxide removal device known as the thermal amine scrubber. This device not only purges carbon dioxide from the station's atmosphere but also recycles water for oxygen generation, underscoring the importance of sustainable living in space. The day's agenda also saw NASA flight engineer Anne McLean conduct significant maintenance work and contribute to robotics research. She installed imaging hardware on an Astrobee robotic free flyer, which is crucial for monitoring its autonomous docking maneuvers. Meanwhile, Roscosmos flight engineer Sergei Ryzhikov worked on Earth observation studies capturing images of natural and anthropogenic disasters, while flight engineer Kirill Peskov operated the European robotic arm for inspections. Just days prior to this busy schedule, the SpaceX Dragon cargo spacecraft successfully splashed down off the California coast, completing a month-long mission during which it was docked to the ISS. The Dragon returned to Earth with valuable science experiments and research samples, marking another successful chapter in NASA's commercial resupply efforts. In a fascinating turn of events, astronaut Nicole Ayers recently captured breathtaking footage of the northern lights from the ISS. While documenting severe storms, she unexpectedly witnessed the auroras, a vivid display of greens and purples caused by heightened geomagnetic activity. I was attempting to catch the huge storms that moved through both North and South America and had a pleasant surprise, Ayers shared, highlighting how such celestial phenomena contribute to both scientific data and the visual splendor of space exploration. As NASA and its international partners continue their efforts aboard the ISS, the integration of advanced technology and research promises to unlock new frontiers in our understanding of life beyond Earth. With the ongoing studies and innovations in life support systems, the future of human spaceflight looks increasingly promising. As we look ahead, the potential for longer missions and even deeper space exploration remains tantalizingly within reach, fueled by the knowledge gained from these pioneering efforts in low Earth orbit. In a breathtaking display of natural beauty, NASA astronaut Nicole Ayers recently captured stunning footage of the northern lights from the International Space Station ISS. This unexpected spectacle unfolded as Ayers was initially focused on documenting severe weather patterns across North and South America. Sharing her surprise on the social media platform X, she remarked, "The aurora showed up this last weekend when I wasn't expecting it. I was trying to capture the massive storms that went through both North and South America and got a nice surprise." The video, which has captivated viewers with its vibrant hues of green, blue, orange, and red, showcases the aurora borealis illuminating the night sky over the northern United States and Canada. The phenomenon is a result of solar activity, particularly geomagnetic storms that occur when charged particles from the Sun collide with Earth's magnetic field. These interactions create the colorful light displays that have mesmerized stargazers for centuries. Ayers, who has been aboard the ISS since March 2025 as part of NASA's Crew 10 mission, has been actively sharing her experiences and observations from space. Her work not only highlights the beauty of our planet but also contributes to scientific understanding. "We see beauty while scientists see data," she explained, emphasizing the dual nature of her imagery. Her posts have included time-lapse videos and photographs of Earth, offering a unique perspective on geological features and atmospheric phenomena. The recent surge in auroral activity can be attributed to heightened geomagnetic conditions, with the National Oceanic and Atmospheric Administration (NOAA) reporting a KP index of 6. This index measures the strength of geomagnetic storms on a scale of 0 to 9. And a higher index correlates with more intense and widespread auroras visible from both Earth and low Earth orbit. In the past months, the northern lights have been visible across various U.S. states, with notable displays recorded even in regions not typically known for their auroral sightings.
Air's stunning footage serves as a reminder of the interconnectedness of our planet and the cosmos. As scientists continue to study solar activity and its effects on Earth, the insights gained from such observations can enhance our understanding of space weather and its potential impacts on technology and communications. Moreover, Air's experiences aboard the ISS underscore the importance of human exploration in the pursuit of knowledge and the appreciation of the natural wonders that exist beyond our atmosphere. As we look to the future, the exploration of space and the study of phenomena like the Northern Lights will likely continue to inspire wonder and curiosity. With advancements in technology and ongoing missions to the ISS, we can anticipate even more breathtaking discoveries that deepen our connection to the universe and our place within it. In a remarkable testament to human ingenuity and the relentless pursuit of knowledge, NASA's ongoing efforts aboard the International Space Station ISS spotlight the delicate interplay between space health research and advanced robotics. On May 27, 2025, the expedition's 73 crew engaged in a variety of essential activities designed to enhance our understanding of human physiology and microgravity, while also ensuring the operational integrity of the station itself. At the forefront of this endeavor is a comprehensive biomedical research initiative aimed at deciphering how prolonged exposure to weightlessness impacts the cardiovascular and immune systems of astronauts. This research is crucial as it informs the development of tailored exercise regimens, nutritional plans, and therapeutic interventions necessary for maintaining astronaut health during extended missions. Humans continue to learn how to survive in space after millennia of evolution in Earth's gravity, noted Mark Ed Garcia, a NASA spokesperson. The data collected from these studies contributes to an expanding repository of insights into space biology, allowing scientists to better understand the adaptations required for long-term space travel. Two astronauts, Johnny Kim from NASA and Takuya Onishi from JAXA, played pivotal roles in these investigations. Kim utilized the Echo teleoperated ultrasound system to conduct remote scans of his cardiovascular health, while Onishi processed biological samples to assess how spaceflight affects cellular immunity. This collaborative approach not only enhances the understanding of individual health metrics but also fosters a spirit of teamwork and innovation in the pursuit of scientific knowledge. The crew's responsibilities extended beyond health research to include robotic inspections and maintenance of life support systems. Notably, astronaut Anne McLean was involved in upgrading a carbon dioxide removal device, a critical component for ensuring a breathable atmosphere in the station. The thermal amine scrubber, as it is called, represents a significant advancement in life support technology, demonstrating NASA's commitment to developing sustainable solutions for future missions. Meanwhile, the recent return of the SpaceX Dragon cargo spacecraft marks another important milestone in the ongoing resupply efforts to the ISS. After a successful month-long mission, the Dragon safely splashed down off the coast of California, returning essential scientific experiments and research materials back to Earth. This cycle of sending and returning cargo is vital for maintaining the momentum of scientific inquiry conducted in orbit. In addition to the ongoing research aboard the ISS, exciting developments are taking place on Earth as students engage with NASA through various internship programs. One noteworthy participant is Jorge Abdiel Carmona Trejo, a student from Waco, Texas, who has been selected for the prestigious STEM Enhancement in Earth Sciences summer internship at the University of Texas at Austin. Funded by NASA, this program immerses students in real-world research projects, fostering the next generation of scientists and engineers who will continue to push the boundaries of space exploration. Simultaneously, researchers at Baylor College of Medicine are pioneering a new initiative known as GeneStar, a protocol aimed at tracking how space travel affects human health. This program highlights the increasing recognition of the need for comprehensive health monitoring as commercial space travel becomes more commonplace. Space is a harsh environment. Microgravity, radiation, and isolation can all affect the body in ways we're only beginning to understand, remarked Dr. Harshadatta Panini, a leading researcher in the field.
By analyzing biological samples from space travelers, Genostar aims to illuminate the genetic and physiological changes induced by spaceflight with potential implications for healthcare on Earth as well. As these diverse efforts unfold, they collectively contribute to a deeper understanding of life in space, preparing humanity for future ventures beyond our planet.
The synthesis of health research, robotic advancement, and educational outreach not only underscores NASA's commitment to innovation but also sets the stage for the next generation of explorers. Looking ahead, the integration of advanced technologies and collaborative research will remain pivotal in shaping the future of space exploration, ensuring that as we reach for the stars, we also safeguard the health and well-being of those who venture into the unknown. NASA's recent announcement of the Mars Roundtrip Success Enabled by integrated cooling through inductively coupled LED emission Mars ICICLE marks a significant milestone in the agency's ongoing quest for human exploration of Mars. As the public's fascination with Mars continues to grow, NASA is diligently laying the groundwork for a future where humans can not only visit the red planet but also return safely to Earth. The Mars ICICLE concept outlines a groundbreaking approach for efficient, flexible, and productive round-trip missions to Mars. A key element of this initiative is the need for improved long-duration storage of cryogenic propellants in a variety of space environments. Among these, liquid hydrogen LH2 is crucial for high-specific impulse nuclear thermal propulsion (NTP), which can be strategically deployed in advance of crewed missions. According to Aaswath Pattabhi Raman from the University of California, Los Angeles, if enabled, such LH2 storage tanks could be used to refill a crewed Mars transfer vehicle (MTV) to send and bring astronauts home quickly, safely, and cost-effectively. However, a challenge persists in the form of cryogenic liquid boil-off, a process where cryogenic propellants absorb heat from their environment, causing them to vaporize and escape into space. This loss can significantly compromise mission efficiency. The Mars ICICLE concept proposes a revolutionary solution, a propellant storage system that achieves zero boil-off (ZBO) through the use of electroluminescent cooling (ELC) technology. This innovative cooling approach enables the storage tank to maintain cryogen temperatures below boiling points, thus preventing losses and reducing mission costs. The implications of this technology extend beyond Mars missions. By allowing spacecraft to refill propellant tanks after reaching orbit, the need for larger, more complex rockets for single-use missions can be mitigated. This could revolutionize not only crewed missions to Mars but also future explorations of deep space. This well-designed cryogenic propellant storage tank can reflect the vast majority of photons incident on the spacecraft, Raman explains, emphasizing its efficiency in various thermal environments. In conjunction with these advancements, the upcoming 2025 Humans to the Moon and Mars Summit H2M2 will convene leaders from government, industry, and academia to discuss the technologies and policies necessary for future human space exploration. Scheduled for May 28 and 29 in Washington, D.C., the summit will feature panels on crew safety, sustainable habitats, and the role of commercial spaceflight. Chris Carberry, CEO of Explore Mars Incorporated, underscored the significance of the moment, stating, "By the end of this decade, humanity will return to the surface of the Moon. We need to work together to ensure that we follow up this achievement by landing humans on the surface of Mars in the 2030s. As NASA continues to push the boundaries of human space exploration, the integration of innovative technologies like those proposed in the Mars ICICLE concept will be essential. The collaborative efforts highlighted at the H2M2 summit will be pivotal in addressing the complex challenges of long-duration spaceflight. With a commitment to sustainable lunar and Martian exploration, the future of human interplanetary travel looks increasingly promising. The advancements we see today may very well set the stage for humanity's next giant leap, landing on Mars. As humanity stands on the brink of a new era in space exploration, the upcoming 2025 Humans to the Moon and Mars Summit H2M2 in Washington, D.C. promises to be a pivotal event. Scheduled for May 28 and 29, the summit will gather key stakeholders from government, industry, and academia to discuss the technologies, policies, and partnerships necessary for humanity's ambitious return to the Moon and the first crewed missions to Mars. with an array of expert panels and discussions. The summit aims to shed light on the future of human spaceflight and the collaborative efforts required to make these monumental missions a reality. The H2M2 hosted by Explore Mars Incorporated will take place at George Washington University's Jack Morton Auditorium, running daily from 8:30 a.m. to 5:30 p.m. Eastern Time. For those unable to attend in person, the event will also be available via live webcast, ensuring that a global audience can engage with the discussions. "We live in consequential times," remarked Chris Carberry, CEO of Explore Mars, emphasizing the urgency of our current space exploration endeavors. By the end of this decade, humanity will return to the surface of the Moon. We need to work together to ensure that we follow up this achievement by landing humans on the surface of Mars in the 2030s. This year's summit arrives at a crucial juncture as NASA's Artemis program aims for a lunar return by 2027, laying the groundwork for future Martian exploration. With 55 nations signed on to the Artemis Accords, a framework designed to promote peaceful and collaborative exploration of space, the summit will spotlight international partnerships essential for deep space missions. Panels will address critical topics such as crew safety, the challenges of long-duration spaceflight, sustainable habitats on the Moon and Mars, and the role of commercial spaceflight companies like SpaceX and Blue Origin. Notable figures from the space industry will take the stage, including Vanessa Weish, Acting Associate NASA Administrator, who oversees human spaceflight operations. Weish will participate in a fireside chat alongside J.R. Edwards, President of Explore Mars Incorporated. Other distinguished speakers include David Limp, CEO of Blue Origin, who will discuss the company's vision for lunar and Martian exploration, and Dr. Shauna Pandya, a physician astronaut candidate who will delve into the physiological and psychological demands of spaceflight. The discussions promise to be rich and insightful, with a focus on the implications of these missions not just for space exploration but also for international cooperation and technological advancements. Tariq Malik, editor-in-chief of Space.com, will lead a panel on new evidence supporting the viability of human life on Mars, further emphasizing the practical aspects of these ambitious plans. As the summit approaches, anticipation grows regarding the potential breakthroughs and collaborations that could emerge from these discussions. The convergence of government entities, private industry, and academic institutions is vital for the successful navigation of the complex challenges that lie ahead in our quest to explore the final frontier. Looking forward, the outcomes of the H2M2 will likely influence strategic decisions and investment in space exploration for years to come. With humanity poised to take significant strides toward establishing a presence on the Moon and Mars, the summit stands as a testament to our collective aspiration to explore beyond our planet and to unlock the mysteries of the cosmos. As we embark on this journey, the partnerships forged and the ideas exchanged at this summit could very well shape the future of human space exploration.